Hello class, this is just a brief introduction to JMP, learning how to download a data set and do some basic descriptive statistics within JMP. So within the content, you hopefully see there's a folder here, data sets for our textbook, and here is, I'll just go ahead and click on that folder. And this is actually the zip file for JMP datasets. The other zip file is for Excel datasets, but I'm going to download this file here, and so there you see it is downloaded. And what I'm going to do here is I've got to go to, within my computer, I've got to go to my File Explorer, and I'm going to go to Downloads. And this file here, I'm actually going to copy it and go to my desktop. Let's see if I can do that. Go to my desktop and say create here a new folder. So here's a new folder with, let me rename it as Stat 520 Data Files. Okay. And I'm going to open that folder. Now I'm going to paste that zip file in here. And I'm going to right click on it and choose the extract files here, and there's another folder, and there are the JMP files for our textbook. Now what I would like to do is I would like to go to a JMP file that deals with exercise, let's see, exercise number 324 from our textbook. And so if you have, hopefully you have JMP already running, I'm going to open this with JMP, and JMP here is opening up in the window. Now I want to show you briefly what this data is about. So let me bring over here is the PDF of the textbook. 324 deals with tax rates for 3 groups of large cities. And so if you look at the data starting with Detroit, Michigan, all the way down to Honolulu, you see the rates are decreasing there. So they've been ordered for us, and they've been grouped as well. Okay, so you have group 1, these cities, group 2, these cities, and group 3, those cities. And so I'm going to go back to JMP here. The way that data came in through JMP, and it would come in your Excel file in a similar way, looks like this. The first column tells me what group I'm dealing with, the second column tells me what city I'm dealing with, and then the third column tells me what rate I've got. Now, the city has lost the name. JMP in the data set has just attached a number to it. So, but that's okay. And so if I want to look here, so for example, suppose I want to do some descriptive statistics. Let's compute the mean, median, and mode of all these rates. Now, one thing I want to talk about first is each of these data columns, they have a data type, and within JMP, the blue triangle tells me I'm dealing with data that's quantitative and continuous, and it was already inputted that way. But when I look at group, it's really, when you think of group, yes, there's numbers there, and yeah, that's a number, but it's really just a categorical feature. So I'm going to change group from being this blue triangle here that represents quantitative. I'm going to change it to nominal. So that's the kind of data I'm dealing with. It's categorical, and I can do the same thing with the city. So I'm going to change city to nominal as well, because those numbers are just placeholders for a group and a city within a group there. But the rate is in fact numeric, and I'm going to keep it as continuous with the blue triangle. The red histogram looking thing here tells me nominal. If you have a green one, it tells me you're dealing with ordinal ordinal data. Okay, so let's just do a few descriptive statistics. The nice thing about JMP is that everything is the base point for your analysis is a spreadsheet, and so it looks like Excel in that sense. You could have typed this data in if you want to. I imported it. It made things a lot smoother in doing it that way, but you can definitely type the data in if you want to. But suppose I just want to do some basic descriptive statistics. The common approach to do that is to go through this tab Analyze, then Distribution, and Analyze Distribution. Now I've actually have three columns that I can analyze. I can analyze the group, city, and the rate, but I just want to analyze the rate. I want to see what's the average rate, what's the median rate, and this sort of thing. And so JMP, I click OK there, and JMP does a lot of descriptive statistics just through that feature. Now I'm going to change this here. Actually, if I left click on this triangle, it suppresses all that output. Left click again, it brings it up. Same thing here. I can suppress that output for the rate. But what I want here, I'm going to right click on the triangle. Actually, I'm going to left click on that red triangle, and I'm going to click stack. I just like the way that looks better. But if I look here at the descriptive statistics, I see I have a mean of 1.77. Okay, so JMP gives me that sample mean of 1.77. The median here is 1.565. All right, JMP gives that to me in a quick manner. In fact, JMP gives us all the quantiles or percentiles, as they're sometimes called, for this data set. And so, for example, say the 90th percentile is 3.19, and so we would interpret that number 3.19 as a tax rate that is higher than 90% of all the other tax rates. And this tax rate of 0.682 is a tax rate that is higher than 10% of all the other tax rates, but it's on the low end relative to the rest of the data. Okay, so here's our measures of relative position, these quantiles here. I have the mean, 1.77. Measure of dispersion, here's the standard deviation, 0.9597. If you square that, of course, you get the variance of the data set. These other values, standard error, mean, upper 95%, and so forth, we'll talk about those later. Here is some of the graphical data description. So let me see if I can enlarge this window. Oh, didn't want to do that. I'm going to try to enlarge this window. So here's the histogram for the rates, and that's if you look at it, you can tell that there's some right skewness going on. We have some somewhat extreme values on the right tail of the distribution. The box plot is given here. So you see the box plot, it has a long right whisker and a larger right part of the box compared to the left part of the box, and so that also indicates some right skewness in the data. And so because the data is right skewed, I'm not too surprised that the sample mean, 1.77, is bigger, a fair amount bigger than the sample median of 1.565. Okay. A couple of other features within JMP that I like to show you. This is kind of cool. If I want to know, hey, what data points are represented by this bar in the histogram, I can left click on that bar, and it tells me I'm dealing with this data point. If I want to know what data deals with the bars in here, it's these data points from row 11 down to row 20, and so that's kind of a cool feature as well. Another thing I want to show you here is how to look at this data from a bivariate data description perspective. So suppose I take Analyze, and I want to do I'm going to use this platform called Fit Y by X, and you use Fit Y by X if you want to do bivariate data description. It's the go-to platform within JMP to do bivariate data description. But I'm going to treat rate as in my Y column or vertical column, and I'm going to just say here group as the X or factor column as it's called here. And if you look at this legend within JMP, this tells me that if I have continuous versus in this case nominal, I'm dealing with this what's called one-way. It really means one-way analysis of variance. That's what that refers to. We'll talk about that later. But it allows me to get side-by-side box plots. If I had continuous versus continuous, then I would get a scatter plot of the bivariate data. But as it is here, I have continuous versus nominal, so I'm going to get some side-by-side box plots. So I'm going to click OK here. And here is, actually I don't need it that large, but let me enlarge this window a little bit. So here is the data. It's a scatter plot there. You can see group 1 has rates that are higher than group 2 and that are group 3, and not too surprised. I'm not sure what the motivation was for the groups, but as you look at the data on the tables, you're not surprised that the rates are ordered this way. One thing we can look at though is we can look at the rates for group 1 and see that they're more dispersed than the rates for group 2 and group 3. Okay, so let's get here. Let's get the box plots. Okay, so I want to go to display options and go to box plots, and there it gives me 3 box plots. This is a much wider box plot than the second and the third group there. If I wanted to get some descriptive statistics per group, I can do that here. So if I want, say, means and standard deviations, I have here within this option, if I'm dealing with group 1, the mean is 2.923. If I'm dealing with group 2, the mean is 1.592. If I'm with group 3, the mean is 0.797. Then here's the respective standard deviations for the 3 groups. And if you look at group 1, the standard deviation is 0.6. The other 2 standard deviations are much smaller, and so that just numerically tells me what the box plots are illustrating, that the variability in group 1 is much larger than the variability in groups 2 and in groups 3. Okay, and so this is a way to look at data in a group by group case. Again, I did that under Analyze Fit Y by X. My first analysis was Analyze Distribution, and it just looked at just the rate by itself, ignoring what group it came from, and the overall average rate was 1.77. And this sort of thing. And I think I can get, if I go back to this Fit Y by X picture, I think I can get a plot of that. I can get it to display the mean, maybe the grand mean there. Let's see. Oh, it was already on there. It was already on there. There it is, 1.77. So group 1 and everything in group 1 is above the grand mean. Everything below everything group 2 and group 3 is below that mean of 1.77. Okay, so anyway, this is a quick video introducing you to using JMP to do basic descriptive statistics, measures of central tendency, measures of dispersion, some basic graphs, histogram, box plot, and then also some basic bivariate data description techniques. Okay, I hope this has been helpful.